Okay, gang, I just did ln of x, but let's talk a minute about derivatives that are not base e, because when you talk about ln of x, I think we all know this. This is basically log base e of x, right? We don't usually write log base e of x. We give this one a nickname. So when it's base e, we call it ln. And I was showing you the derivatives of that on the previous, right? We talked about that previously. The derivative ln is 1 over x. The composite ln is 1 over the inside times the derivative of the inside. Now, for those of you who are mathematics, engineering, some kind of STEM major, I just want to go over this other case so you can see at least. I'm going to do it very briefly so you can at least see it. So this is if it's not base e. Like, what if you had y equals log base 5 of x? Okay, log base 5. So then you have to follow these rules here. So this means that you have to do 1 over the inside, as we know. We know 1 over the inside. So it's 1 over x. There's the 1 over x part. But then it has that extra case where you have to take the ln of the base. So the base here is 5. So I have to write ln of 5. So this is for a non-composite. And again, you notice this didn't show up with the ln case, because if you do ln of e, this goes to 1 and it disappears. That's why it's only 1 over x. So when it's not base e, it has this extra ln of the base here. Now, if you have a composite, it's a similar idea. You have to have the base, you have to have 1 over the inside, and then you have to have the derivative of the inside. So let's try this one here. So the derivative of this, right, you have 1 over the inside, so 1 over the 2x, that's the inside. You have to do ln of the base is 10, so ln of 10. And then you have to do the derivative of the inside, u prime. So derivative of 2x is 2. And then you notice when you simplify this, the 2's will reduce. So you get 1 over ln 10 times x. Okay, gang, so again, engineering, mathematics, STEM, this stuff is more for you. But again, I might give extra credit, so if anybody else is interested, or we're game on that. Now I just also want to point out in your book page, in the PDF, page 163, there's just like a nice summary of the rules that we've done so far. We've got the constant rule, the basic power rule, the constant multiple, sum and difference, product, quotient, chain. This is power rule with like chain. You have an inner layer in it. You've got all your trig. The only thing that's really missing here is, like composite U, composite ln, and then it's got those other ones that I showed you that I may give as extra credit when I write the test. This one and this one I was going over. Okay, so this is like a really nice table. All right, when we come back in the next video, I want to talk about, because what I'm showing you now, we're working on like doing the e's for the homework and the ln's. And by the way, if you know your ln properties, and I'll write them down real quick for you. This could be log base 10 or log base e, it doesn't matter. The rules apply to all of them. Remember, if you have a product that breaks to addition, if you have division that breaks to subtraction, if you have an exponent, that can come down as a coefficient. So I invite you to outsmart me and use any of these log properties while to sort of, you may decide to prep the problem before you take the derivative. Like this one, I would take the log property. I do ln of cosine x minus ln of cosine x minus 1. I'd use this, because that's going to make solving this a heck of a lot easier. But I'm going to leave that to your discretion. If you want to do derivative of the outie times derivative of the innie using the quotient rule, that's fine. It's all correct. It's just your simplification step will be a lot more difficult. So I'm going to invite you for the logs to use the log properties if you would like. You're not required to do so. All right, so the last video, I want to focus on second derivatives because I'm going to ask you second derivatives, but also you have to make sure you've sort of simplified your first derivative before you jump into your second derivative. Okay, gang, so when we come back, I want to talk a little bit about this. Catch you soon. Bye-bye.